So, so we have based on the type, we have glass mask and transparency mask. So glass mask, we would have a slab of glass on top of which the features would be made with the chromium layer. So as I discussed that the glass mask is a little bit expensive, however, it is long lasting. Its life would be 1 year. We could reuse it again and again. On the other hand, we have transparency mask. ट्रांसपेरेंसी किन शीट्स नॉर्मली जो शीट वी आर यूजिंग फॉर बाइंडिंग वो कवर्स वगैरह के लिए नॉर्मली यूज करते हैं ट्रांसपेरेंसी शीट थिन शीट ट्रांसपेरेंट शीट so that thin sheet is used in the high resolution printers. So we have high resolution printers. Manufacturer would have high resolution printers, and in the high resolution printer they would print the features on top of that transparency mask. So transparency mask is low cost. If the, for example, when I was working, the price of the glass mask was $100, whereas the price of transparency mask was $1. So there is a huge actually difference between the price. However, you could use the transparency mask for 1 or 3 or 4 5 runs. After that, actually, it is not recommended. Otherwise, your features would be not transferred as efficient as you want. So you have to use the transparency mask 2 times or 3 times, not more than that. So here you see the mask. So we have glass mask and transparency. Other classification that we are doing is the light field mask and dark field mask. So light field mask, the feature would be opaque. The light field mask, the feature would be opaque to the light, whereas the remaining portion, which we call the field would be transparent. The light could pass through the remaining portion. Only the feature would be opaque. So such type of mask is known as light field mask. The light could pass to the field. It could not pass to the feature. So we called it light field mask. Here you could see this is a light field mask. This is the opaque portion. The light would not pass. And this is the remaining portion which we call the field of the mask. It is actually the light could pass through it. It is transparent to the light. So this is light field. So this is the feature, and if we have a mask and the feature is opaque to the light, while the remaining portion of the mask is transparent to the light, then that mask would be known as light field. However, if the feature is transparent, and the field is opaque to the light, here you see that in this mask, the field is opaque. It is not allowing the light to pass through. However, the feature is transparent. So this type of mask is known as dark field mask. So also, normally it is very important when you are making the mask. So the manufacturer needs to know that whether you want a light field mask or dark field mask. You have to mention that in your email or in your file that I want a dark field mask or light field mask. If you are not giving that information to them, they would again ask you to email that you have sent us the layout of your mask layer, but actually which layer or which layout is you want a light field mask or for which you want a dark field mask. So before actually starting the manufacturing process, you have to make a mask. You have to decide whether you want a glass mask or you want a transparency mask or whether you want light field mask or dark field mask. तो ये कैसे डिसाइड करेंगे लाइट चाहिए डार्क चाहिए it depends upon the type of photoresist what photoresist you have or which type of photoresist you are using, whether you are using negative photoresist or you are using positive photoresist. Which photoresist is available in your company in your clean room, or which photoresist your supervisor is buying for you. So similarly also, for example, uh, as I discussed with you that the glass mask is expensive. It is $100, $200. On the other hand, the transparency mask is $1. So for trial purposes, we start normally with the transparency mask. If there is some error in our drawing or in our, for example, thinking in our design, then the fabrication cost or our would be less if our mask is $1. On the other hand, I send the layout to manufacturer. Let's say he made 10 masks. For me, 10 masks means $1,000. And at the end, I come to know that, the features which I have made on the mask, it is our size, or I don't want like that on my device, and I want to change the features on my layer, and already you have spent $1,000. So for example, if you are working in a company, so your boss would be unhappy with you, and if you are working in a university as a research student, then your supervisor would be very very angry that you have spent $1,000 and you come up with nothing. So normally before actually the fabrication, you have to look upon all those things. Also in the software which I discussed with you, that is the MEMS Pro for winter wear. In these software, you could actually also simulate for the fabrication. So there is provision in the software. You have made the mask. Next to the software, you could simulate the fabrication process and the outcome of the fabrication process. You could simulate that. आपने software में the software, you have to go there and you have to simulate your mask. These are my masks and these are my layers. ये layers हैं silicon dioxide, silicon nitride, aluminium, and these are the layers and these are the masks and these are the process steps. First, I want to deposit silicon dioxide and then photolithography. Then I want to deposit silicon nitride and then the photolithography. Then I deposit aluminium layer and then photolithography, and I have to use these masks for the photolithography, and the software would give you the outcome of the substance. So that is another way where you could check your mask. Mask अभी नहीं बने. You could check the layout of your mask. You could check the process, and you could check the outcome. Once everything is confirmed already, everything is correct, then you have to order for the mask. And once the masks are there, you have to buy the photoresist, and then you have to start your service. Here again, we see mask. As I told you that we have glass mask, transparency mask, dark field mask, bright field mask. So here you see that these are the features, and features are opaque to the light, whereas the field is transparent. So this is a bright field mask. Whereas on this this schematic or figure, you could see that the field is opaque to the UV light, whereas some of the features are transparent to the UV light. This is a dark field mask. Now coming about the photoresist. So photoresist is actually normally organic polymer, but it is highly sensitive to ultraviolet light. Its chemical property changes when the photoresist is exposed to UV light. When UV light falls on the photoresist, a chemical reaction takes place in the portion which is exposed to UV light. And because of that chemical reaction, the chemical property of the portion which is exposed to UV light changes. So the portion which is exposed to UV light, its chemical properties will be different, and the portion which is not exposed to UV light, its chemical properties would be different. So normally the portion which is exposed its chemical property is different. So we have to put that into a developer solution. And developer solution, we have designed the developer solution in such a way that it would etch only that portion which is exposed to the UV light. Because its chemical properties has changed, so the developer will only eat that portion which is exposed to UV light. So positive photoresist exposed PR would be gone. Yeah, gone. G missing. Exposed PR would be gone. The portion of the PR that is exposed to light becomes soluble to the PR developer. Negative photoresist exposed PR would stay. The portion of the PR that is exposed to light becomes insoluble to the PR developer. For photoresist, normally, generally, we use the notation PR, photoresist. So generally, people would be saying PR, not it would be not saying photoresist. So PR is the abbreviation that we use for the photoresist. So again, we have a mask, and on the mask you see a feature substrate, and on the substrate we have spin coated the photoresist, and we want to transfer this pattern on the substrate. Again, that depends upon the type of photoresist which you want to use. If you are using positive photoresist, then the same feature would be transferred on the substrate. Positive, the same feature would be transferred. इसको positive इसलिए कहते हैं the same feature that we have made on the glass, it would be transferred to the substrate. If you look here, the same feature which we have on the mask, you would see the same feature on the substrate. That's why we call it positive photoresist. However, if you look here, the reverse of the feature has been transferred. The feature is this, but the reverse of the feature has been transferred on the substrate. That's why we call that photoresist negative photoresist. So if we have a negative photoresist, so the reverse of the feature would be transferred on the substrate. Normally, photolithography process takes place inside the clean room. Clean room के अंदर करते हैं. The whole fabrication process normally takes place inside the clean room because we are actually doing fabrication in a very small scale, micrometer, nanometer, and where a small particle of the dust and dirt or human hair would destroy or ruin your whole fabrication process. So the whole process is done in a very clean environment. This is the bench, laminar flow bench, where you could perform the photolithography. And here you could see the normally uh, photoresist, small beakers, big beakers, there could be big beakers. So hot plates. So normally, first what you have to do, you have to clean your wafer. First, you have to clean your wafer. You have to wash your wafer with isopropanol. Isopropanol. In fact, this bench, you have to wash it with isopropanol. You have to wash it then with the deionized water. In the clean room, deionized water, all tapes, water tapes will be deionized water. So first you have to wash it with the isopropanol, then you have to wash it with the DI water, and then you have to dry it with the nitrogen gun. Nitrogen is an inert gas. It would not react with any chemical on your wafer. So you have to dry that with the nitrogen gun. Then you have to put the wafer on the spinner, and you have to set the speed आप लोगों ने basically randomly set नहीं करनी है, arbitrary set नहीं करनी. Normally for each photoresist, the recipe would be given by the manufacturer. आप लोगों ने catalog देना है. If you are using that photoresist, go to the catalog of that photoresist or download the recipe. उस रेसिपी में मेंशन होगा कि भाई if you want to deposit this much layer or thick layer of this photoresist on your wafer, then you have to rotate your wafer at, let's say, 500 rpm for 1 minute. 500 rpm for 1 minute. So you have to use their instructions. So let's say I'm using the photoresist. I have went through their catalog or recipe manual, and I found out that, so if I have to deposit, let's say I am depositing 100 nanometers of the photoresist layer on top of my wafer, and I want a uniform layer. I have to put it on the spinner, and I have to rotate it 500 rpm for 1 minute. After that, I have to remove my substrate, and I have to put it on the hot plate. This is the hot plate. This is the hot plate. I have to put this the substrate on the hot plate. Oven भी होंगे, normally heat oven. You could put in the heat oven. वो भी recipe soft, we call it soft bake. Soft baking में क्या करते हैं? The soft baking, what we do, we put the when we deposit the photoresist on the substrate, we have to put it on the hot plate or inside the oven. And in the recipe, it would be mentioned that for the soft bake, you have to keep your wafer at 120 degrees centigrade in the oven or hot plate for 1 minute. For 1 minute, I have to keep my wafer on the hot plate or inside the oven at 120 degrees centigrade. इसलिए करती कि जो आपका फोटोरेसिस्ट है उसमें जो फिर वाटर वेपर्स हैं वो evaporate हो जाए और it gets a little bit hard. We call it soft baking. Soft baking इसलिए करते हैं, वो इसलिए करते हैं कि next we have to use the wafer inside the mask aligner. This is the mask aligner. In the mask aligner, we normally expose our wafer to the UV light. So at the bottom, we have to put the substrate or wafer, and at the top, we have to put the glass mask. And both of them should be in contact. Otherwise, the feature banega, that would be not so good. So normally we have two techniques. One is the contact technique and other is proximity technique. Proximity technique means the mask would be close to the substrate, but there would be a slight gap. And in the contact technique, the mask and the substrate would be completely in contact with each other. And it has been found out that proximity technique may actually the resolution that we would be getting, that would be not good. However, in the contact technique, where the mask and the substrate they are in contact, we get very good feature resolution because if there is a gap, then light could pass, the diffraction could occur. उससे क्या होता है कि बेसिकली जो फीचर है उसकी रेजोल्यूशन कम हो जाती है. So in the majority of the cases, we normally do the contact, we use the contact technique where the mask is in contact with the wafer. Photoresist is liquid, so if you are not doing soft baking, so it would be sticky. So if your mask and wafer comes in contact with each other, so it could ruin your photoresist. Because photoresist की layer की thickness कितनी है? It is very minute, few nanometers, and that photoresist would stick to your photo mask. So normally we have to perform soft bake. Soft baking may normally some portion of the humidity or the water content, it would be evaporated, and your photoresist would become a little bit, it would become hard. So we call it soft bake. Soft bake may, after soft baking, your photoresist would not stick to the photo mask. So once we expose the photoresist to UV light, and you have to take out the photo mask, you have to take out the your wafer, and again you have to put in the oven or on the hard plate. जो भी रेसिपी में given होगा, we call this hard baking. Hard baking. We have to make our photoresist layer more hard. So we call it hard baking. Hard baking means the recipe would be provided by the manufacturer. It would be, let's say that you have to keep your wafer after the exposure for 2 minutes in the oven or on the hard plate at 150 degrees centigrade. So on 150, you have to set this hard plate at 150 degrees centigrade. You have to put your wafer there, and it would be there, let's say, for 2 minutes. After 2 minutes, you have to take it out, and you have to allow it to cool down. And after that, you have to put your wafer into the developer solution in order to remove the portion which is exposed to UV light. So normally, photolithography, photolithography, we put masks of the pattern on the mask onto the substrate, and then you have to photolithography from pattern transfer, and next is etching. Because we have deposited a layer of a material on the substrate, but we don't want the whole layer. We want some portion of the layer to stay on the substrate, whereas we want that some portion of the layer to be etched. So the process that in which we remove some portion of the layer from the substrate is known as etching. The process of selectively removing material, it is known as etching. So in this process, we remove some portion of the material that we have already deposited on the wafer. So we have wet etching, we have dry etching, and we have reactive ion etching. Reactive ion etching is also tried. So normally, basically, we have two types of etching. Wet etching, we are using liquid solvents to perform the etching. And in the dry etching, we are using gas or plasma to perform the etching. Wet etching would take place inside the wet bench. We would, in the clean room, we would have a bench which is known as wet bench. It would be a laminar flow bench, but we would be performing or we would be using a liquid solvent, so we call it wet bench. And in wet bench, you could perform the etching inside the beakers. Different size of beakers would be available, and different size, different solvents would be available. And in the beneath the wet bench, in the drawers and in the drawers of the wet bench, photoresist would be there, acids would be there, gases would be there. So all of the liquid material would be in the drawers of the wet bench. Timer, normally very important. Normally the etching process recipe. First we have to read the recipe for etching. The recipe क्या है? Silicon dioxide etch करना है. So which acid I have to use? What should be the concentration of the acid? What would be the concentration of this mixture? Or how much time I have to perform the etching? So either that recipe would be provided by the manufacturer. If it is not provided by the manufacturer, those recipes would be available in the publications, the papers which have been published by other researchers. They have actually mentioned the recipe that I have performed the etching of silicon dioxide. This much was the thickness of silicon dioxide. I have used dilute HF solution. This was the concentration, and I have performed the etching for 30 seconds. So you have to use their recipe. If that is also not available, then you have to develop your own recipe by hit and trial. You have to perform the experiment and you have to develop your own recipe. that for how much time, if the thickness of silicon dioxide is 1 micrometer, so how long I have to perform the process. So normally hit and trial method is that you have to dip your wafer in the HF solution, and then you have to take out, after let's say 30 seconds, I have taken out the wafer, I have washed with the DI water, and then I have dried with a nitrogen gun, and then under the microscope I have to visualize whether all of the silicon dioxide layer have been etched or not. If it is not etched, I will again start the process and start the stop part. I have to remove it again after 10 seconds, and I have to check whether all of the silicon dioxide which I want to etch is gone or not. If it is gone, your process is complete. If it is not gone, again you have to repeat the etching for let's say 5 more seconds. So by this way, you have to develop your own recipe for the process. Uh, Also, we use gases to etch the layers. That type of etching is known as dry etching. And also, we have reactive ion etcher, where we use plasma. We supply a gas, and under a high electric field, the gas is actually disintegrated into plasma, and the plasma actually reacts with the layers, and it would heat the layer. This type of etching is known as reactive ion etching. The ions would be eating, the ions in the plasma would be eating the material. So this type of etching process is known as reactive ion etching, generally known as RIE. Etching, normally we have two types of etching, isotropic etching and anisotropic etching. Isotropic etching, normally the rate of etching would be same in all directions. The rate of etching would be same in all directions. In this direction, in this direction, in this direction, all directions, the rate of etching would be same. For example, if we have a substrate and I put this substrate into an etchant, and the etchant is isotropic etching, we would have two types of etchant, isotropic etchant and anisotropic etchant. So if the etchant is isotropic etchant, it would eat the material equally in all directions. So if I put this wafer in an isotropic etchant, so this would be the outcome after some time. A hemispherical pit would be formed inside the substrate. This type of etching is known as isotropic etching. And this isotropic etching would be performed by isotropic etchant. Isotropic etchant. So that solution which heats the material equally in all directions. That is isotropic etching. Here you see that we are performing another process, which is that is RIE, reactive ion etching. The material is etched in only one direction. You could see that we are eating the material and only in one direction. So this type of etching is known as anisotropic etching. Anisotropic etching, the rate of etching is different in different directions. The rate of, you could see that in this direction, the rate of etching is very high. However, in the lateral direction, the rate of etching is almost negligible, zero. So this type of etching is known as anisotropic etching. The rate of etching is different in different directions. So normally the etchant which you are using, so first you have to make it sure that whether that etchant is isotropic etchant or it is anisotropic etchant, whether it would heat my material equally in all directions or its etching rate depends upon the direction. It heats material differently in different directions. So that is very important. So you have to first confirm whether you have to perform isopropagation or anisopropagation. So depending upon that, you have to select the agent. In this table, you could see some agents for these materials. The materials are silicon, gallium arsenide, silicon dioxide, silicon nitride, aluminium, and gold. And these are the agent composition. So if you want to etch silicon, so this is the actually the composition of the agent: 3 ml hydrofluoric acid plus 5 ml nitric acid. And if you use this etchant composition, then the etch rate would be 3.5 into 10⁵ angstrom per minute. Gallium arsenide, 8 ml sulfuric acid, 1 ml hydrogen peroxide, and 1 ml water vapor. And it would etch gallium arsenide by this rate, 0.8 into 10⁵ angstrom per minute. Silicon dioxide, 28 ml HF, 170 ml H2O, and 113 grams ammonium chloride, and the etch rate would be 1000 angstrom per minute. Silicon nitride, buffered HF or hydrophosphoric acid we would be using, and etch rate is 5 angstrom for HF, and hydrogen phosphoric acid, which is 100 angstrom per minute. Aluminium, 1 ml nitric acid, 4 ml acetic acid, and 4 ml hydrochloric acid, and 1 ml water vapor. Water. Etch rate is 350 angstrom per minute. Gold, 4 gram calcium iodide plus 1 gram iodine plus 4 ml water vapor, and etch rate would be 1 into 10⁴ angstrom per minute. So normally these recipes would be given. These recipes would be given in books. It is taken from a book. These recipes would be provided by the manufacturer. These recipes would be available in the publications. And if they are not available, then you have to make your own recipe. You have to find out the efficient composition of the agent solution, and you have to decide about the etch rate. So what is the etch rate? So वो आप लोगों ने फिर खुद करो. I think it's sufficient for today. If you have questions, तो questions वगैरह पूछ. If you have questions, तो वो पूछ लो. Question है? Hello?
No, sir.
कोई क्वेश्चन वगैरह तो पूछना, डिस्कशन करनी है तो पूछ.
No, sir.
No, sir.
चलो सही है, नहीं है तो फिर मैं लेक्चर खत्म करता हूँ. ओके, थैंक यू. ओके, खुदा हाफिज़.